Hi, I'm Greg Petsko. I'm professor of neurology and neuroscience at Weill Cornell Medical College in New York City, where I direct the Alzheimer's Disease Research Institute. 110 years ago, Alois Alzheimer, a young neurologist in Germany, was presented with a patient, August Dieter. Ms. Dieter was suffering from dementia, and she was, in fact, the first person ever officially diagnosed with what we now call Alzheimer's disease. You might not know it to look at her, but she was 51 years old when this picture was taken. Alzheimer's disease is a disease of aging, but it's not exclusively a disease of the aged. There are hundreds of thousands of people under the age of 65 with Alzheimer's disease in the United States. She was, in fact, dead about 3 years after this picture was taken. And when Alois Alzheimer autopsied her brain, he found things that shouldn't have been there. One was on the outside of the dying neurons, and he called those senile plaques. And you can see them here. Okay, these are the original pictures that he drew of these things. These are the senile plaques he saw. And they contained aggregated protein. We now know they contain a fragment of a larger protein. That fragment is called A beta, and the larger protein is called APP. Inside the dying neurons, he saw an additional phenomenon. He saw tangles of a different protein. We now know that protein is tau, and it's a microtubule-associated protein. Similar aggregates of different proteins are found in the brains of patients with many different neurodegenerative diseases. Parkinson's disease, frontotemporal dementia, mad cow disease, Huntington's disease, and so forth. So the phenomenon is somewhat of a common one, even though the specific proteins that form these aggregates do differ from disease to disease, and the regions of the brain that are affected also differ from disease to disease. That may, in turn, lead to a variety of different larger structures, such as oligomers, fibrils, or the dense tangles of fibrils that form these macroscopic aggregates that I was telling you about. Now, if you look at the plethora of species that are produced, it's hard to be sure what the toxic species is that's killing the neurons in these diseases. The consensus is that it's the oligomeric species, but that's not established completely. I've indicated it that way on this slide, but that's really still a hypothesis. Virtually all of them, Huntington's is an exception, virtually all of them are mostly sporadic and idiopathic. That is to say, they pop up randomly and we have no idea what causes them.